Okay, welcome back. So in this video, we're going to expand on our previous visualization using this new website. And so I'm going to go ahead and reset and go to normal. This is what it will look like when you click on this website. And I'm going to pull up our past visualization to help kind of ground us a little bit. So it's kind of a lot squeezed into one window here, but hopefully you can stay with me. So to get this to look like this, so first off, we have population distribution. And what that's doing is it's letting us select what this should look like, right? Because remember in the last one, this represented the population distribution. And so if we want it to look normal, we can select normal. But this one, we started out flat, so let's go ahead and do that. So that's continuous uniform is what we want there. And then we have statistic mean. Let's just stick to the mean because central limit theorem here, we're talking about the mean. You can play with others if you'd like to. Then we can change sample size and samples to draw at one time, which directly relates to sample size and draws over here, right? Because again, sample size is the number of participants per sample. Samples to draw is the number of samples we're collecting. And so if we draw one, then we'll see one over here. And so now what we see is all sample values and simulated sampling distribution of the sample means. And so what the simulated sampling distribution represents is this part of our other distribution. All right, in other words, frequency, what was percent over here, now it's showing frequencies. And it's showing the values on the x-axis. I guess on this one we can't necessarily change the values of our x-axis. We'll get to that in the next one. I'm getting ahead of myself. And so just like this one, if we wanted to do 50 draws, we'll click 50 samples, and since we have a flat continuous uniform distribution here, we essentially see that in the sampling distribution, right? Because we don't have a large enough sample size. So let's do the same thing over here. Let's make it 50. And if we draw, right, this one actually looks a little bit more normal. But in the aggregate, we'll see basically the same thing. If we continue drawing samples of 50, right, we can see that this is not a normal distribution, right? All sample values, this is the aggregate, like all of the sample values together. This is the sampling distribution of sample means. Here they match because our samples are size 1, so these are going to be identical. If we kick up the sample size to 10, then we'll start to see some differences there, right? And also, too, you'll notice now we have a normal distribution because what happened? We have a large enough sample size, right? Just like we did in the other distribution. If we kick this up to 10, we do that, right? Because that's the central limit theorem in action, right? With a sufficient sample size, our standard error is going to decrease, and we'll see a normal distribution in the sampling distribution, right? And so let's now go to normal. So a normal distribution here is going to be the same as this here, right? So now what we're saying is the population distribution should look like this, right? And then let's go down, or actually, let's just stick to this. So let's stick to the mean. Mu and sigma, what we're changing there is the population mean and the population standard deviation. And sample size and draws are going to be equivalent. And so if we do just 1 and 1, right, so now we can see that our scale here, our x-axis, is hovering around 100, and that's because that's our sample mean and sample standard deviation, right? So here the sample mean was 117.8. Right, and that's what shows down here is it's telling you the most recent sample mean. And so if we continue doing this, right, just like the other one, we could do this and we'd slowly work towards a normal distribution. Here, because our population distribution is a normal distribution. But let's go ahead and kick it up. Let's do 10 and 10. Right, and we click that a few times, so we can see here that all sampled values, this frequency is increasing, because again, this is every sample we've collected all compiled together. So each time we click, it's adding to those sample values. And then over here, the sampling distribution, right? That is, like we said, equivalent to the sampling distribution on the other one, right? And so here we can see that we have a narrower distribution than on the other one. And if we increase the sample size even more and keep doing this, now we're seeing an even narrower distribution. But this scale is really big, so let's kick this down to a smaller scale to see things a little better. So now our population mean is going to be 10, our sigma, our population standard deviation, is going to be 1. Let's just stick to 1 and 1. And so now we can see our x-axis is much narrower, right? Or it's smaller units, so it's probably a little bit easier to interpret. Right, and so we can keep doing this. So now we're seeing these sample means coming in around that population mean. And so we continue doing this. Let's go ahead and do 100 samples at once. And there we can see it, right? All our sample values, in this case, they're essentially identical because their sample size is 1. So all the sample values, these look the same. Let's kick the sample size up to 10. And by doing that, even here, we're seeing a narrower sampling distribution because, again, increasing the sample size, especially when we have a normal population distribution, is decreasing the standard error here and showing us a much narrower sampling distribution. Some of the things I didn't show is we can click show stats, and that's just showing some additional stats here. So we can see tree population mean equals 10, that's what we set it at. Aggregate mean equals 10.1, so it's just all these things together. Sampling distribution mean is 10.01, right? So very close to that population mean. And the sampling distribution standard deviation, or the standard error, is only 0.31. And then show parent distribution, I forget what this does. Oh, that shows the the overall population distribution. So we change it to continuous uniform, right? Then we can see that it's flat, right? And I'm curious what negative exponential looks like. Okay, yeah, so this is essentially a heavily skewed distribution, right? And so hopefully this kind of gives you something to go off of as you go about playing with this on your own. And again, the overall purpose of these visualizations is to help you to understand what we're talking about with the central limit theorem, because even for myself, it's one of those things that took a while to really click. And so through using visualizations like these, I was able to kind of start wrapping my head around it. So yeah, we'll go ahead and stop there. Let me know if you have any questions. We'll see you around.